So hi and welcome to this webinar from Stena Circular Consulting on the topic of life cycle assessment. Today we will talk in particular about how LCA can be used for recycled materials and through the circular economy lens. And we will go through a few different case examples. My name is Oscar Michelson, but we will make proper introductions in a moment. First, I'll briefly introduce you to Stena Circular Consulting. Stena Circular Consulting is part of Stena Recycling Group, the largest industrial recycler in the Nordics. We work to enable circular business solutions by providing insights, advice, and recommendations connected to circular design, waste management optimization, circular business models, and circular strategy. Today, we will talk about LCA and how that can be used to drive design choices and develop circular businesses. We will go through customer cases from different industries and ending with listening to insights from Better and their LCA projects, which was completed a few months ago. So my name is Oscar and I have a background in engineering and technical design. I have specialized in LCA in combination with design and circularity. Hence, my core expertise lays in how to apply and use the learnings from an LCA efficiently, as well as using LCA to find business opportunities and increase circularity in an innovative and data-driven way. With me here today, I have Torbjörn from Better and my colleague Alex. Torbjörn, would you like to introduce yourself?
Yes, so I am Torbjörn Lantz, and I have a Master of Science in Metallurgy is my background, and since 2 years back I'm the Managing Director of Better in Guldsmedshyttan in Sweden, and Better is a group of foundries and machine shops manufacturing parts for OEMs into the wind energy, and that is to Vestas and General Electric and Enercon, for example.
Hi everyone, my name is Alex Kovbasko. I'm a strategy consultant and I will support Oscar and Torbjörn with the Q&A at the end of the webinar.
Thank you, Alex and Torbjörn, for introducing yourselves. This is the agenda for today. So first you will have to listen to me while I'm giving you a brief introduction to LCA for those who are new to the subject. Then we will go into why circular economy is a useful lens to apply to life cycle assessments. I will give you examples of how LCA can be used in a more strategic and design tool rather than just a reporting tool. And then we will deep dive into how recycling impact in particular is calculated and examples of how the LCA scope can be extended to show the benefit of recycling and other circular strategies. And last but not least, Torbjörn will take over and tell us about his recent experience of doing an LCA project and what they thought was the most valuable insights and learnings. There will be a Q&A session in the end. You can write your questions to us using the Q&A feature in Teams. Let's begin with a short introduction to the fundamental concepts of life cycle assessment. You can't manage what you don't measure is a quote made famous by the business management expert Peter Drucker. And in essence, this is what LCA is all about. Life cycle assessment is a measurement method, and the purpose of measuring your environmental impact is to be able to manage it better. Often, environmental impact also aligns with economical parameters, and by measuring both economic and environmental impact, you can identify the most effective strategies and actions to increase circularity and minimize environmental impact while remaining profitable. A common misconception is that LCA is just about CO2, but actually it's a broad perspective scientific method. A proper LCA includes 5 important fundamental principles. The first one is to set a good goal and scope of the LCA, and this is really key to get valuable results. Getting it wrong can either result in extra unnecessary work or in the worst case, a result that is useless. Second, gathering accurate but not excessive LCA, so-called our life cycle inventory data, is another important cornerstone. This is the backbone of the LCA, and a good rule of thumb is to follow the 80 principle here and gather accurate data where impact is the largest while keeping other data collection optimized. Third, as I said in the beginning, many associate LCA with CO2 footprint, but really an LCA should measure several parameters, impact categories. And I will explain more about this on the next slide. Fourth, it is also essential to interpret the result of an LCA objectively and from different perspectives. It should not be communicated as just a number. Environmental impact always depends on multiple factors and is no exact science. Therefore, the LCA result comes with a lot of conditions, and the result of an LCA is actually better described as a range of possible results. Lastly, you must not forget that the purpose of why we do an LCA and the purpose of the LCA methodology is to safeguard things that we want to protect, which is not only the climate, but also things such as human health, biodiversity, freshwater access, and a range of other things. Here you see just some examples of impact categories. Each impact category are then measured by so-called indicators. So for example, the most common indicator for global warming potential is CO2 equivalents. The ICO standard for LCA recommends assessing at least 3 impact categories. Which ones to measure is typically industry or product specific. Good to understand is that when conducting an LCA, measuring several impact categories typically does not require a lot of extra work, as they are already integrated in most LCA software. There are standardized methods for measuring all impact categories with rules regarding to the time frame of the impact and so forth, but I will not go into these technical details today. And this list is non-exhaustive. My main message here is to encourage you to see the broader perspective and avoid a tunnel vision on CO2. Let's look a bit closer at the LCA scope. The scope of an LCA can cover anything from just one process or the entire life cycle of a product. The typical process steps in an LCA is raw material extraction, manufacturing, distribution, use, and disposal. So for example, you can measure just one single step, for example, distribution, and then the result could be the impact of driving X kilometers with a truck. Or it could be a range of processes. For example, one very common scope is from cradle to gate, and that is raw material extraction plus manufacturing, so to the end of your manufacturing gates, basically. And then the result could be the impact of producing one product of a certain model. Cradle to grave is considered the full life cycle. To close the loop, I would like to add a separate step, reuse or recycling. And sometimes the negative impact, or so to say, the negative impact of, for example, recycling can be included in the disposal step. But in many cases, the circular business model are more complicated, adding, for example, return transports or washing processes. So to exemplify, the result of a cradle to grave analysis for a reusable packaging product could be the impact of sending goods from point A to point B 100 times. And in this case, the reused or recycled product, of course, would have an advantage over a single-use product in the raw material and manufacturing steps because fewer products are needed, but they would have an extra impact from additional transports and processes. And as long as the impact of reuse and recycling step is lower than the extra from manufacturing and raw material extraction, it will have a lower impact in comparison with a single use case. We will go into more details with our case examples about this later. Okay, now let's look at 4 different client cases or client case examples of how we have used LCA beyond reporting. Because today LCA is typically used to accommodate the 3 aspects here to the left. And while these are all good reasons to doing an LCA, like complying to regulatory requirements, meeting customer requests, or just showcasing your benefits over a competitor, you are missing out on many valuable benefits that an LCA study could also give you by stopping there. With the right product expertise and expertise in circular solutions, recycling and material sourcing, more values can be unlocked. And I have divided them here in 4 different use cases, and I will describe one client case on each one. So the first use case with is pinpointing high impact design changes. And this is more relevant maybe for product designers. The second use case is about identifying innovative business opportunities. And this is relevant, for example, for business developers and CEOs. The third use case is particularly interesting for persons working with purchasing or supply chain specialists. While the last case about quantifying the impact of recycled material content is actually interesting for designers, purchasing, as well as CEOs or business developers. Okay, well, let's go into the first case. Pinpointing high impact design changes is a high priority for many of our customers, and many companies I've worked with do this already. One good example here is an LCA for an off-road machinery manufacturer who approached Stena Circular Consulting to learn the differences in environmental impact between different product models. And they also wanted to see a little bit about what strategies they could use to reduce the impact. In this case, we also evaluated photochemical oxidation or air pollution and toxicity. Some product design takeaways were that a new different operations technology that they had in one of their products reduced the whole life cycle impact by half. So that was a very strong message to sell their new product, their new technology. Second, we saw that electrification strategies showed great potential, but faced challenges with market implementation. We could also see that the combustion engine was the main contributor to the impact, highlighting the need for modernization. The product was also really highly adapted for repair and remanufacturing, and that significantly reduced the raw material extraction impact. So in essence, highlighting that they already did good work on that. We could also see that the economic and environmental benefits aligned over a longer time frame, which made the design implementation easy to motivate. One key to enabling this use case or this use of the LCA is to bring on board product design expertise in the project, either through internal or through external expertise. The second use case is about finding opportunities for innovative circular solutions. And this is not as common as the first area, but we try to do this with all our clients. In this case, there was a furniture manufacturer who wanted to offer a range of remanufacturing service solutions for a wooden bench to one of their largest B2B business-to-business customers. And by modeling the economic and environmental impact for 3 options, they could transparently communicate with their client. And so the first option was to replace the entire bench after 10 years, which was the status quo, what they normally did. And then we added an option, and that was to wash the bench, grind the surface, and apply a new varnish and paint. And also a third option where the full wooden top was replaced, and we applied new paint to the other parts after 10 years. And in the end, the client went with the more circular option B, successfully transitioning from a previous linear business model to a more circular one. The third use case is about discovering supply chain improvements. So since an LCA requires detailed product and material data, asking the right questions to the upstream supply chain can provide valuable insight about your product. In this case, an recycled polyester product, we discovered that a non-recycled liner accounted for actually more than 40% of the product weight, even if the product was marketed as 100% recycled material. But the supplier could provide a verification of the actual recycled content through a third-party agency upon request. This virgin material and non-recyclable liner could also be made thinner and be replaced with a substitute that maintained the desired product properties, which in the end improved the LCA result. Okay, the last area or use case to gain additional value from LCA is about quantifying the impact of recycled material content. This category is similar to the first one, or the one about finding opportunities with innovative circular solutions. But while focus there was about changing the business model, this is more limited to quantifying and comparing the impact of certain percentage of reuse, recycling, or remanufacturing. And here I'm actually using Better as a case to give you a brief point of view of our side of the project. Better uses recycled cast steel in their product, as was shown in the LCA study, which Torbjörn will tell you more about later. The increased recycled content showed a high reduction potential, both for material extraction and for the transport emissions. And generally speaking, recycling or other circular options would have a positive impact if these three things are true. So if the material extraction step is where most of the impact is created, if detailed data about the circular solution is available, and an extra pointer is if the circular solution has logistical advantages. So in other words, if the virgin material comes from far away, while the recycling, repair, or washing, for instance, is done locally. Okay, and this last use case brings us on to my last topic before I'm handing over to Torbjörn. In this chapter, I'll briefly try to explain what's the most important things to think about when you wish to calculate the impact of recycled materials for your product. Okay, so basically there are three main key factors to understand when it comes to calculating the environmental impact of recycling. First, you must be sure about the scope and what impact you're comparing with, because if you want to showcase the benefits of recycling, it's all about comparison. Make sure that the scope of all scenarios is the same and realistic or based on real data. This can be a bit tricky, so make sure that you have a careful set of assumptions of what you're doing. Second, you should understand the difference between closed loop and open loop recycling, where actually true impact is only achieved if you're actually using recycled material yourself. So simply sending material for recycling, so-called open loop, only poses a potential reduction. Third, it's important to understand that using average factors just gives an indication, as should not be communicated as actual reductions, because it very much depends on the application of the material in its second life, as well as market factors and much more. The average factors from databases are often used for comparison, does not take all of these things into account. Additionally, can be old data or the recycling with a different technology, for example. So all these 3 points in together when it comes to recycling means that it's usually a unique case by case. To elaborate a little bit on the third point, you must understand the recycling process a little bit, or why less accurate with the recycling data if you just use average factor. Because most of the emissions from the recycling processes for Stena and also other recyclers actually comes from transport emissions. And that's because the value chain for the full process is on a global scale. That means that finding a local recycler and local material will impact the environmental impact a lot. And this makes the average data inaccurate in most cases. The good news is that most recyclers like Stena typically have this data, and they know their processes and they know where their downstream partners are located. So Stena Recycling, for instance, has a very detailed mapping of their waste stream flows, all the way from collection to the creation of new circular resources. It is currently limited to CO2 equivalents, but it means that for almost any material, we can understand the actual climate impact for clients to Stena. And they can already access this data through the Stena customer portal. But this data can also be used for modeling more advanced scenarios for recycling, for example, with increased recycled content, like we did for Better, with alternative sourcings and transports, etc. And we can use the knowledge as a base for recycling scenarios in other markets and by other recyclers than Stena. So you are not actually limited to being a Stena customer. Yeah, okay. I hope I've managed to give you some insights to the circular economy twist of life cycle assessment, in particular, the impact of recycling. I'm now very happy to hand over the word to Torbjörn, whom I had the pleasure to work with during the end of last year.
Yeah, thank you very much, Oscar. I hope my voice is a little bit better.
Yeah.
Yeah, take the next slide. This is a picture from how it looks like inside our plant there. So, yeah. Just a short brief about Better, because it's not the company that everyone knows about. But we here in Guldsmedshyttan, we started as with a foundry 1868. So we've been here for a long time and done a lot of different things here in the foundry. And also we had that blast furnace here. So really been in the steel industry. But 2003, we was acquired by Vestas. And then we started to cast parts for the wind industry, and that we continue with until 2000. Well, we still are, but 2014 we were sold, and now we call the Better Group, and we have a couple of foundries around on the world. But our main parts that we are casting is a hub, is main bearing house, and main shaft that are really sitting in the nacelle up in the windmill. And this is parts that is 15 to 20 tons each. It's not so many foundries in Europe, for example, that can do it, but it's much more around in Asia, of course. A little bit more about Better Group. We have foundries in Sweden, like here in Guldsmedshyttan. We have one in China. In India, we built a greenfield plant in 2021 during the COVID time, and we acquired a foundry in Germany here last year that was a part of Enercon to really get access to them as a customer. And we do then machining and painting of the parts in Denmark, China, and India. So this is what we are doing, and foundry business are this kind of large parts. And European foundries cannot really fight with price. So when we did the strategic overview, we said that the only way we can really have an instrument to compete with is the CO2 emission. We had done just a pre-study of circularity with Stena, and we had a lot of discussions about CO2 emissions, different things, and we decided to do then a credit to Gate here together with Stena Consulting, and what we did was only focusing on the casting part, in a matter of fact here. And what they're saying here is also that we're looking into the CO2 tons per ton finished cast products that we do. So that's a little bit background of the company and what we are doing as a company. You can take the next slide. And we as a company, we have been focusing quite a lot on scope 1 and scope 2. What you do in Sweden, I mean, we had the contract for electricity of 50% wind and 50% hydro energy, that we have it as an EPD class electricity. So we have been very low emission on electricity, as you can see on this result of the LCA. And before we really did the study, we have done some changes, like we put in HVO in the forklift, and we see that we were able to calculate that was significantly better. It was really to understand the big picture, including scope 3, why we decided that to be able to talk with customers, to be able to discuss with suppliers, we need to do the LCA, and this is the result of it. And to explain a little bit more about what we are doing, I mean, we are doing ductile cast iron, and really what we're using is pig iron. We're utilizing steel scrap. We're using chips from our machine shop, so we have a circularity there, plus our return iron, as we call it, like the ingate system, what is left over in the basin and so on. And we use electric furnaces and melt it. And we as a company, we are quite a big user of electricity. Is plus 20 gigawatt hours that we're using here. So the importance for us to have a good electricity, what we call EPD classified electricity, is really an advantage here. And also what we can see from the result, and was also is the last comment here, that the emissions are the biggest differentiation compared to the benchmark. After we have done the melting, we are pouring it into large sand forms, where we're using 90 to 95% reused sand with what we call here consumables, and that is resin and activators. So that is how the different, and of course we're having alloying material in the pig iron, scrap and so on as well. And the result here is really that the impact is the pig iron is 55% of the total emission. And so it's a big chunk of emission coming out from the pig iron. And of course also alloying material, and what we're talking about there is ferrosilicon, quite a lot. And all the transport as well, because the pig iron or the ore is coming from far away, Brazil or Senegal, in matter of fact. So it's a long distance for the transport into that. And as a general, when we're looking into this, I have decided not to show the exact value of CO2 per ton that we emission, because it's really a part of further discussion we will have with our customers. But we can say we are significantly lower than a normal foundry, and we looking in some numbers and comparing with, for example, some Chinese suppliers, we are probably like 60-70% lower in CO2 emission, and mainly based on the electricity emission on that. But this is what I believe, not what we can show, in matter of fact. Yeah, next slide. You can say more or less, when we started this, we were, like you, Oscar, describe it as a tunneling focusing company, just looking in the CO2 equivalents here. But of course, it's other factors that is important for us as a company as well. But I'll leave it to you, Oscar, here to explain a little bit more here.
Yeah. So you started to look at only climate change and CO2, as you said, and I actually think that's a good starting point. Also, that you had a limited scope, only looking at the casting process as a first step. But you were also very curious to understand what other indicators are there, and what should we look at in a bigger picture and in the future. And so we did this analysis as part of our report to you as well. And there we could see that ecotoxicity and particulate matter was two of the indicators that really stuck out from, in particular, the pig iron production as large impact contributors. So I don't know, it shows like a relative impact on this graph. So you can see that climate change, while it has a relative impact, still it has an impact, and there's other more to the right here. There are other indicators that also have a large impact and should be not forgotten.
Yeah, so when we did this LCA, we also discussed a couple of different scenarios, because it's something where you are, but also where can you go and where can you improve. And of course, it was easy to start to look in the pig iron, because we as a foundry always looking into what the steel industry is doing, and low emission steel is made of 100% scrap, and yeah, we can of course replace pig iron with more scrap, and that was what we really calculated here. We're going down from 37% pig iron to 25% pig iron, and increased the steel scrap. The challenge for us as a foundry is to find the right quality of steel scrap at that big amount, because we need very low manganese steel scrap, because we cannot refine in our furnaces, we can only melt. So that is a challenge for us. But we are already working in how can we reduce pig iron, because that is such a big impact into our footprint. And this is this is a project that is involved a lot of people in our company, with the R&D and also supplier and so on. And exactly like Oskar said here before, a significant portion of this is that instead of using pig iron coming from Senegal and using steel scrap that is really coming from local here, we also get the double reduction effect, because it's less transport. And for us as a company, the LCA was really done because we wanted to have more knowledge. We can start to talk with our customers in a better way, and we said that we need that to increase our knowledge in the company to understand what is the scope 3 and the total LCA, and that gives us a much better position to talk with our. On the pig iron suppliers, we need to have including the scope 3 and complete LCA. Suppliers are really good in talking about scope 1 and scope 2, but looking at ourselves, it's really in the scope 3 where everything is located, so to say, regarding CO2 at least. And of course, it's helping. We as an industry are working with our suppliers now. And I think this is an important step forward to continue with that. And that is also about other actors, of course, around to work with the LCAs. And we are planning to do an LCA both with our Indian plant and China's plant as well, to understand what kind of impact it's having and compare with this, because our customers are asking for it. And I think that's all from me.
Yeah, thank you, Torbjörn. And yeah, it was very fun to work with you, and thanks a lot for being here with us today. We have now come to the Q&A session. So I will stop sharing my screen, and I think Alex perhaps has some questions for me or for Torbjörn.
Thank you so much for the presentation. We have 2 questions from the audience, and I suggest that's where we start. And a reminder to everyone listening to us, feel free to post them in the chat. We might be able to cover them all actually this time. There's a question from Felix Maya, who's curious about the eco-friendly materials such as composites. And what are some of the pointers that you would give to the companies that are selling these sort of materials that could be contaminated with organic fibers, pork, wood, wheat, so forth? How would their LCA look like?
Yeah, I guess I will try to answer this question. It's a little bit of a complicated question. So I would like to advise them to look into their local market and where it's sold and what's the actual recycling capabilities in this market, because these kind of mixed materials are often very difficult to recycle. So while maybe an LCA can have a good footprint, so to say, in the manufacturing and raw material phase for that kind of material, it will probably not have that good of a result in the disposal phase. So trying to see the bigger picture of what will happen to the material in end of life, and together with a local recycler, investigate that further.
Thank you, Oscar. And probably the question to you and Torbjörn together, could you clarify the comparison of the impact factors in the better example? In what dimension was the particulate matter worse than the climate change impact results?
Yeah, so I can start answering, and then I don't know if Torbjörn wants to fill me in. So when we didn't check the total result, the detailed result for all of the indicators. What we did was more of a screening of what kind of indicators are interesting to look at, and then we use something called a single point index, where you summarize kind of the results divided for the average emissions by one person, a global citizen. And then from that kind of perspective of what are people emitting today and what's the budget of each kind of emissions. So that's kind of the relative scale that we're using. And there's no unit, because there's a different unit for all of these indicators. So it's more of a relative comparison, and it's not an exact comparison either. It's just to give an indication of where you should look.
And do you take into account the financial costs of different options when you do an LCA?
We did not look that much into that, Torbjörn, in your example maybe, but so there we took, in the LCA study, we made some scenarios like Torbjörn talked about, and then it's up to better to kind of use that result and those learnings and see what's the feasibility and viability of implementing that. But it is something that we have done before with other clients, where we are looking at both economic and financial point of view, seeing kind of where is the break-even point, where is it break-even from an economical perspective, and where is it break-even from an environmental perspective, and trying to find a sweet spot where it's both financially and environmentally sound.
I can add respond to that as well, because in today's competing business, we're always looking what is the cheapest way. But when you get this LCA, you can think outside the box suddenly and rethink in what can you do if a customer is able to pay for it. And of course, we're always looking at alternatives in how our supply chain can look like and what can be done there. But it's really opening a really nice box of tools that you can work with.
And maybe the final question to both of you, do you have any recommendations on how to get started with an LCA for somebody who has not worked with the tool before?
Well, I can say from my perspective, and I think it's important that the management team is very do this for the future for all of us, and I think that was a good support to really run it from my side, because I thought it was important. It was easy to get the information and to happen very quick as well. So I think that this is a good item to bring into the discussion. Is always to have the management with you.
Yeah, and that's a really good insight, Torbjörn. And I would also maybe like to add that I would recommend to start small, like similar to what Petro did. Maybe start with only looking at CO2, if that's typically the easier way to start if you haven't done it before. And also narrow scope. So it's also similar to what you did, Torbjörn, to look at not maybe the full process, but a part of the product or one product if you have a range of products, for example, and also to not do it alone, but to get help with doing it if it's the first time.
And what kind of tools or databases do you use when doing an LCA? And you've mentioned, Oscar, that the data, the averages are not usually great. So why is that?
Yeah, so I typically use a database called EcoInvent, and it's good because it contains a lot of materials and from many different markets and so forth. And it works very well if you're looking for commodities or materials that you buy on a global market. But when it comes to purchasing of a recycled material or recycling processes, it does have a lot of regional differences. So here it's difficult. You can sometimes have also good quality there, but you need to read the data sheet carefully and understand it better. And also, I also use this Stena internal data a lot when it comes to recycling.
Thank you for sharing. We have one last question in the chat and 1 minute to go. So let's try to make it crisp. Fatima is asking, biocomposites mostly come with polymer matrix. In that case, how can we decide from circular aspect? Do you think it's important to use digital identification of bio-based composites?
I think it's important to trace where the material is going. If you do that by through a digital tracer, or if you just do that by other, like mapping the value chain, both are good ways to do it. The main point is maybe to understand that already at the design table where what kind of material are you using and where does it end up in end of life to ensure circularity.
Thank you very much. That's all for today. Torbjörn, thank you so much for sharing your insights and being with us today.
Yeah. Thank you, everyone.
Thank you very much.